In this video, I'll demonstrate how to code these two open pockets. Open pockets are coded almost the same as any other contour requiring multiple passes. The material being cut is 6061 aluminum, and I'll use a 5mm high-speed steel 2-flute end mill with a cutting speed of 120 meters per minute and a feed per tooth of 125 microns to cut this open pocket. To rough these features, I'll first feed the tool to 0.5 millimeter above the pocket bottom, then arc into the cut and feed to the center of the radius at the far end of the open pocket. Because 100% of the cutter is engaged, I'll cut the feed rate in half. Next, I'll rappet the tool 2.5 millimeters above the part, then across to the other side, where I'll cut this side. After both sides have been roughed, there will be 0.5 millimeter on the floor and 1 millimeter on the walls. I'll remove this with another 5mm slot drill. Since the tool is already on the right side of the part, I'll finish this side first by programming the tool to climb mill the open pocket profile. The cutter path as shown in the upper left-hand corner of the screen will be coded using cutter compensation and incremental programming. Since all of the arcs sweep through 90 degrees, the X, Y, and R values will all be the radius of the part geometry. The only consideration will be if the X and Y values are positive or negative. After this side is cut, the tool will wrap it above the part and reposition to cut the left side open pocket. The tool will first be positioned using the absolute coordinates, and the cutting will be coded in incremental. In the next video, I'll demonstrate how to program the tool to enter the larger pocket.